As we go into topic 6 of module 4, we're going to be introducing a new type of number. That is the complex number. And to do this, we're going to give you a little background. And you recall that we had said that if we have the square root of a negative number, that's not a real number. So mathematicians had a problem with this, and to be able to work with this, they developed a new kind of number in a sense. They'll be called complex numbers, where we divide this up into the square root of -1 and the square root of 4. Now remember, the square root of -1 is not a real number, but we can define it as the letter I. So the square root of -1 in the future will be the letter I. Now, when mathematicians worked on this, they referred to this as sort of an imaginary number, and that's where the I comes from, imaginary. But it's not really imaginary, it's something that they use to calculate things with. But the imaginary title stuck to it. So that's what we use. So let's work with that a little bit. We're saying I equals the square root of -1. Well, how about if we square this, as we've been doing? Well, this becomes I squared. And remember, there's a index number of 2 there, and 2. And then we just becomes the radicand. So I is equal to the square root of -1, but I squared equals -1. And that's sort of a key thing that we're going to use throughout our calculations with complex numbers and imaginary numbers. That anytime we have an I squared, that's going to be converted to a -1. Okay, so let's do some work here. We're saying the square root of -3 again is going to be the square root of -1 times the square root of 3. We're saying the square root of -1 is I, the square root of 3. Now this can also be written the square root of 3 and then put the I afterwards. Now the problem with this is sometimes you might extend the radical sign to include the I. By having the I in front, that prevents that happening. So this is sort of the preferred way, but this is the way you'll see in the future. We'll show you that that's really the proper way to write it, but this way is completely acceptable. All right, for letter B, we have the square root of a -81. We know that's going to be a -1 out of there is I. And the square root of 81 is 9. Or, again, the way to write that is 9I. Now here there's no confusion, so the I is written afterwards. Now for letter C, we have the negative, and that's important that we have the negative there, a negative 48. So this is, again, the negative is there. We're going to take out the I. Then we have the square root of 48, which is actually the square root of 16 times the square root of 3, if you recall. What is the square root of 16? 4. So we have negative I for the square root of 3. Now, this could also be written, remember, is negative 4i, the square root of 3, or negative 4, the square root of 3, with the I over there. This way is the preferred way, but all of these are correct. All right, let's move it up and go on to example 2. Now, in example 2, we're adding imaginary numbers. And over here, we're subtracting imaginary numbers. Now, the same rules apply to when we were just working with a variable. So a suggestion would be you put them in like term columns. Now again, you might do this mentally, but this is just a suggestion. And if you want to put a 1 there, that's fine. Now for this subtraction, again, we can put the first one there. And now, since it's subtraction, we have to change each of these signs. So here, this is positive, so we make it negative. This is negative, so we make it positive. This is just a strategy, but you get the right answer. So let's go on to letter 3A, where we have the square root of a negative 9 times the square root of a negative 49. Now, when we're dealing with complex numbers, we can't multiply the negative times the negative under the radical sign. That we cannot do. So we must use another method. And the method is to convert this to its complex form or imaginary number form, which will be the square root of negative 1, which is I, and then the square root of 9, which is 3. Here, the same. Square root of negative 1 is an I. Square root of 49 is 7. So we now go 3 times 7 is 21. I times I is I squared. And we know that I squared is a negative 1. So this becomes a negative 21 for letter A. Now going on to B, we have the square root of negative 8 times the square root of negative 11. Another thing to keep in mind is if the radical sign is 2, the index number of the radical sign is 2, then the negative underneath that indicates that this is an imaginary number. So this is going to become I, funny I there, the square root of, now notice 8 is the square root of 4 times the square root of 2 from a previous lesson. and this will become I, the square root of 11. So now we can take the square root of 4, which is 2, which will give us 2I, the square root of 2, times I, the square root of 11. So I times I is I squared, so this gives you 2I squared, the square root. Now we just multiply our radicants of 22. But we know again that I squared is a negative 1. So this will become a negative 2, the square root of 22. This is a negative 5I times 4I. So we can just multiply our numbers, a negative 20 I squared. But what did we say I squared was? A negative 1. A negative times a negative makes this a 20. Notice we're going from imaginary numbers to real numbers now. All right, let's go on. Now here we have a negative 6I times a negative 2 plus 7I. We're in a sense multiplying a monomial by a binomial. So we just distribute actually. This will be a positive 12I. A negative times a negative makes it a positive. Now this is going to be a negative 42I squared. But what did we say I squared was? A negative 1. So this is going to become 12I plus 42. Now, what we're looking at here is something I didn't comment on yet. And that is A plus BI. This is the proper form of complex numbers, where A is a real number and the BI is an imaginary number. This is the order we put them in. So the real number comes first, followed by the imaginary. Now, is this in correct order then? And the answer is no. This should be written 42 plus 12I. And again, sometimes they'll take off if you write it this way. This is the proper way. Real number followed by the imaginary number. This is the proper form for complex numbers. Now I notice down at the answer column they don't always follow that. I'm not sure who they had writing it out, but we'll follow it. All right, letter E now. 2 plus 5I and 6 minus I. And what do you think we're going to do here? We're going to FOIL. So, going back to our FOIL, this is a 12. Now my outers are a negative 2I. My inners a positive 30I. And my last a negative 5I squared. Now, as we FOIL this, we see we have like terms in the middle. So we go 12 plus 28I 5i. Now, this is going to be a negative 5i squared. But what did we say I squared was? A negative 1. So this becomes a negative 1, and a negative makes us a positive 5. So we want to write this in the correct form. So we get 17 plus 28i. Now notice below they didn't write it this way. They didn't follow their own direction, but we will. Again, they sometimes take off if you don't write it in standard form. Real number plus the imaginary number. This then is a complex number. Okay, now another tool that we're going to use that we have mentioned before, that we would use every once in a while, is what is called the conjugate. So we have here a negative 4 and a negative 5i. What is the conjugate of that? Well, the conjugate of that, you may or may not recall, is the same terms, a negative 4 and a 5i, but here in the middle the sign changes. So these are conjugates. Now, one of the things they ask us to do is to multiply conjugates. So this will be a positive 16. This will be a negative 25i squared. Your inner and outer terms cancel out. So this is a negative 25i squared, but I squared is a negative 1, so this becomes 16 plus 25, or a 41. Now they're not asking us to do that here. All they wanted here was what is the conjugate. And I guess we could just do this. It's 10i. What would the conjugate of that be? Well, it would be a negative 10i. Just opposite sign. Okay, now they're asking us to actually multiply these conjugates. So let's do that. 2 plus 9i. I have trouble making that dot there with my pen. 2 minus 9i. Again, the nice thing about conjugates, there are no middle terms. So our outers, a 4, and our last, a negative 81i squared. What is I squared? A negative 1. So this makes it 4 plus 81, which is 85. So the use of conjugates will be critical for our division that we're going to do here. Again, ask any question. So let's set up the division. Negative 8. Let's try to do that correctly here. Negative 3 plus 8i over 5 minus 4i. Now here we want to use the conjugate of our denominator. So the conjugate of this will be 5 plus 4i. and we have to multiply by 1, so this is going to be the same. So on the top, we're going to FOIL this. So we'll do it carefully. Negative 15. Outers a positive, a negative 12i. Inners a positive 40i. And last, a positive 32i squared. And we know this is going to end up being a negative 32. Okay. Now we're going to combine like terms. Well, let's do our bottom here too. So 5 times 5 is 25. A negative times a positive is a negative 16i squared. But we know that this is going to end up being a positive because I squared is a negative 1. So let's just do that, and we can save a little room here. So this is going to be a negative 32. And what will this be? A 41. So we showed you how to do it, and now we're just saving room a little bit. So what do we have then? We have a negative 15 and a negative 32. That's going to give us a negative 47, and that will be over 41. And this is going to be plus, this is going to be a 28i over 41. Now keep in mind that these are to be written in the form, again, a plus bi. You cannot have it all over the 41. You have to separate it into the real number here and the imaginary number here. And if you could do some canceling in here, that would be needed, but none can be done, and this is the answer. Again, you could put the negative sign there instead of up there, but that's okay. All right, let's go on. We now have another. This looks like it's much easier. 4 plus 7i over 4i. Now we're looking for the conjugate of the denominator. Well, in theory, you might think it's a negative 4i, but I have discovered that in practice, if we just multiply our denominator by a negative I, that saves us lots of simplifying afterwards. Now you could put the 4 there if you want, but then you're going to have to cancel it out later. So it's really easier this way. So our numerator becomes a negative 4i, and this becomes a negative 7i squared. And this is going to be over a negative 4i squared. Now we know that I squared is a negative 1, so our denominator is going to be a 4. and this is a negative 4i, and this is going to become a negative 1 times a negative 7, a positive 7. Now, as we look at that, is that in standard form? No. So, putting it in standard form, it's going to be a 7 over 4 minus 4i over 4. But notice we have a common factor there that we can cancel out, and this just becomes a 1. So our final answer here is 7/4 minus I. And that's what they have below. And I think that's in standard form as well. Yes. Okay, a little background now to our next item, and that is what we call powers of I. So if you would, write this down as a little reference somewhere. In fact, you can write it right up over in here somewhere up at the top. Powers of I. Well, we know that I equals I. And we know that I squared equals a negative 1. Well, what does I to the third equal? Well, can you see that it's an I and I to the second? So we have a negative 1 times I is a negative I. Well, how about I to the fourth? Well, I to the second is negative 1. So I to the fourth is I to the second times I to the second. Negative 1 times negative 1 makes it a positive 1. All right, let's go on to I to the fifth, I to the sixth, I to the seventh, I to the eighth. Notice if we took I to the fourth out of here, that would be a 1, and we're just left with I. So I to the fifth is, let's put it over here, I to the fourth times I. This is a 1. 1 times I is I. And here, if we took out I to the fourth, which is a 1, we'd have I to the second. 1 times I to the second, which is a negative 1, is a negative 1. I to the seventh is I to the fourth times I to the third. We can see it right here. That's a negative I. And then I to the eighth is I to the fourth times I to the fourth, which is 1 times 1, which is 1. So what I've briefly shown you is that there is a recycling of the powers of I. For every I to the fourth that you have in something, that's a 1. So if you take out all your I to the fourths in something, those are just going to be 1s. And then you're left with some power of I, which you use this scale for. So as I look here at I to the 26th, can you see that that is I to the 24th? This is divisible by 4 times I to the second. Well, any power of I divisible by 4 is just going to be a 1. So, and then what did we say I to the second was? A negative 1. And that's the answer to letter A. Now, for 71, if you take 71 and divide it by 4, you get, it goes even, I believe, 17 times. And then there's a 3/4 left, or 17.75. So what is 4 times 17? Well, that is I to the 68th power times I to the 3rd power. Again, this is divisible by 4. Since it's divisible by 4, this is just going to be a 1. So 1 times I to the 3rd. What did we say I to the 3rd was? Negative I. So for letter B here is a negative I. It's just this. Now here we have I to the 41st. Well, I to the 40th is divisible by 4 times I, and we said any exponent divisible by 4 is going to be a 1. I to the 4th 10 times, which is 1 10 times, and you're left with just an I. So for letter C, the answer is I. And that completes our little lesson.